The length of time taken on the SAT for a group of students is normally distributed with a mean of 2.5 hours and a standard deviation of 0.25 hours. So this time they gave us an actual distribution for the regular X. Okay, we're just talking about a randomly selected student taking the SAT. There's a mean of 2.5 and a standard deviation of 0.25 or 15 minutes. All right, this is our mu sub x and this is our sigma sub x that go with that normal distribution. A sample size of 60 is randomly drawn from this population. Find the probability that the sample mean is more than 2.6 hours. So even though the original is normally distributed, I'm not using this distribution to calculate this probability question because they're not asking me about one randomly selected student. If they said, what's the probability that a randomly selected student took the test in less than 2 hours, that would be this right here. One randomly selected student. Well, pretend that there's an extra E in there. Selected student. All right, a regular X represents one individual piece of data. That's not what I'm asked for. What I'm asked for is what's the probability that if I collect 60 people, the sample mean, the average of those 60 people would be more than 2.6 hours. What I'm being asked here is what is the probability that X bar is more than 2.6 hours? And if you get used to writing out this probability question mathematically, every time you read these problems and you know the correct version of X to put in that, then you'll see that, hey, I don't have this distribution yet. I haven't written out the distribution for X bar yet. X bar is normally distributed with the same mean as the regular distribution, but the standard deviation is different. The standard deviation is the old one divided by the square root of n. So that's going to be 0.25 divided by the square root of 60. All right, and again, 4 decimal places should be close enough, at least for the online calculator to get an accurate read, something close enough that MyOpenMath will accept it. So I put this in my calculator and I round to the 4th decimal and I should have 0.0323. That's going to be the standard deviation I use when I go to calculate the sample mean or the average of those 60 students being greater than 2.6 hours. So I'm going to go to that online calculator. I want my picture to look something like this. 2.5 should be in the middle. That was my mean. My standard deviation should be 0.0323 because I'm looking for that X bar. I needed to use the X bar distribution. All right, 2.6 is probably going to be pretty high up there. All right, maybe something all the way over here, just because this is such a small standard deviation. We're adding that 3 times, 0.03, before we even get to 2.6. It's going to be pretty high up there. All right, again, this might not be the most accurate picture, but I'm imagining that it's just that top tail there. The shading wise, we should have this little guy, the left in value shaded on the right. All right, let's go to our online calculator and check it out. We have a mean of 2.5. We have a standard deviation of 0.0323. And then I want to look at the shading to the right. And I want to look at the value 2.6. So again, a little hard to see, but you can see where that little arrow is. Oops, I just moved it, so I'm gonna have to move it again. But this arrow, wow, I didn't know we could drag these. How cool. That's a new feature. All right, 2.6. I can't get it exactly. So I'm going to go in here and I'm going to type it in again. 2.6 greater than, the probability is 0.001. Very, very small chance. There's still a chance. All right, again, practice writing the correct notation. They said the probability of the sample mean, that was our X bar, being more than 2.6 hours. That's how we write that out. And then I just showed you how we put it into that online calculator.